Good morning. What's my topic is X-rays absorption, and what I'm going to give is X-ray definition and its introductions. What are the type it involves? X-ray absorption, X-ray fluorescence, and X-ray diffractions. Now let us go to the definition and the introduction part. X-rays. So what is an X-rays? X-rays are a form of electromagnetic radiations. These X-rays have a wavelength ranging from 0.01 to 10 nanometers. And these X-rays have a wavelength shorter than those of UV rays and typically longer than those of gamma rays. Now we have to know who discovered these X-rays. It was discovered by Wilhelm Röntgen in 1895. How we introduced this by using a crystal experiment. Or what are the experiment he done by using that crystal is he is just passing a cathode ray tube into that fluorescent into that crystal. Now he is getting a fluorescent glow, even though it is taking place in a dark sheet, but some of the glow has been saw by him. So what he is referring them as unknown energy, and he is naming them as X radiations. Okay, now we are naming them as X-rays. Okay, what are the sources of these X-rays are? There are X-rays are sealed X-ray tubes, radioactive sources, rotating anode tubes, synchrotron radio facilities, etc. And what are the analysis? And these X-rays are also analyzing nowadays. So it is widely used sources are X-ray tube and synchrotron facility. These X-rays are also used in some of the medical fields also. Okay, now let's go to the X-rays schematic diagrams. So it is explained in the electromagnetic spectrums. So now we are seeing that there is some radio waves, microwaves, infrared waves, ultraviolet waves, and gamma wave and gamma rays, in which these X-rays are lying in between the ultraviolet and gamma rays, in which these X-rays have a shorter wavelength and higher frequencies. Okay, now what we are gonna see is these are the X-rays which are lying in between ultraviolet and gamma rays, as I told you before. So these are lying between the visible regions also. These X-rays, not in the visible regions. These are infrared and ultraviolet is known as a visible region, in which the ultraviolet and gamma ray, in between the ultraviolet and gamma rays, these X-rays are being notified. Now let us consider the X-ray absorption spectroscopy, XAS. It is simply defined as an XAS. So, okay, what is meant by XAS? X-ray absorption spectroscopy. Now let us consider how it is working. The source of this XAS spectroscopy is X-ray, in which the X-ray is passed through the atom, in which it is absorbed by an atom, and the energy of the X-ray is transferred to the core level electrons. While the core level electrons may be K, L, or M cell, which is ejected. While observing these X-rays, these electrons are ejected from the atom from its orbit. So the atom is left in an excited state with an empty electronic level, in which a core hole is obtained there. An excess of energy from the X-ray is being given to the ejected photoelectrons. So this is the schematic diagram of that X-ray spectroscopy, in which it is passed from the the X-rays are being being passed through the atom, and the electrons from the X-rays are being ejected from that which is named as a photoelectrons. So this is schematic diagram of this XAS absorption spectroscopy.